Good morning, students, and welcome to online physical science class of St. Michaels Academy. Hope you are enjoying the classes. So in this revision lesson, we are going to discuss some examples of Newton's law in a very interesting way. So let's start. So first, I am going to discuss some examples of Newton's first law. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. This is normally taken as the definition of inertia also. Now see this example first. This is a ball that is at rest. These are the forces acting upon it. As you can see, there are only two forces acting upon it, the weight and the normal force. This means that this object is not accelerating and its velocity is constant. In this case, its velocity is 0. This is the ball. This is the weight, downward direction, and this is another force, that is upward direction. No extra force is applied. That's why its position is stationary and its velocity, initial velocity is 0. Now see, same ball. Someone is kicking this ball. Now someone is kicking this ball. That means an force is, see, someone is kicking this ball. That means a force has been applied on this ball so that it's moving. It's getting its velocity and after that it's getting its acceleration. Okay. This example also proves Newton's first law. Now come to this example. Car is moving. Suddenly, there is a wall. That's why car cannot move. But it is that time also it is in velocity only. This man or driver also maintaining its own velocity. That means car's velocity. That's why he has fallen down from the car. Mostly accident happens due to this reason. Because always, generally every moving object generally used to follow, moving and static object used to follow Newton's first law. That's why seat belt is required also. And this is the one of the best cause of accident. Now coming back to this example. This example defines inertia. What is inertia? The tendency of a body at rest to continue in that state is the inertia of rest, and tendency of a body in uniform motion in a straight line to continue in that state is known as the inertia of motion. This accident is also happening due to inertia of motion because they want to continue their speed, their velocity, but due to this wall they cannot. That's why accident happens. So like this man is going to hurt this elephant. But ultimately what happened? He has fallen down. Why? Because elephant has more inertia than this man. See, elephant is only slightly moving. That's it. But the man having small inertia than this elephant has been fallen down. So this also justifies the first law of Newton. In this slide, we are going to discuss about the examples of Newton's second law. Before that, I want to remind you what is Newton's second law. When an unbalanced force acts on a body, then the applied force is proportional to the acceleration produced in it. This is Newton's second law. So Newton's second law states that the acceleration of an object is directly related to the net force and inversely related to its mass. Acceleration of an object depends on two things, force and mass. Clear? Now next, what is the mathematical expression of Newton's second law? Thus the force is the cause and acceleration is the effect of it. You see this example, you will understand. Force is the cause, see, and acceleration is the effect. Force is the cause and on this ball, and because of force, acceleration has been produced on this ball and it is moving fast. Okay, so force is the cause and acceleration is the effect. Next, when a force F is applied to a body produces an acceleration A in it, then from Newton's second law we can say F varies as A. That means we can say F is equal to m into A. So that force is equal to mass into acceleration. The more force we apply, the more acceleration we'll get. See this example. More force is applying for getting the acceleration. But first of all, acceleration is not greater. In second time, when force is greater, that time acceleration is increasing. You see the next event? Yes, now force is increasing, acceleration is also increasing. Okay. Now, come to this example. So, what is momentum? Before this example, I am going to tell you what is momentum. Momentum is the property of a body possessed by virtue of its mass and velocity, and its magnitude is given by the product of its mass and velocity. That means momentum P is equal to m into v. Now, here elephant and ant both have the mass, but mass of elephant obviously is greater than mass of ant. But their velocity is same. They have started falling down from a multi-storied building. That means from a same height. But what is happening? Elephant is reaching the ground more faster than the ant. Ant is reaching, whereas ant is reaching the ground approximately 3 minutes later. Why? Because M1 for elephant is greater than M2, but V1 and V2, that means velocity of elephant and velocity of ant, both are equal and same. But since M1 is greater than M2, that's why this elephant reaching the ground more faster than ant. I'm giving you one example on this, another example, mathematical example. Let two balls A and B of masses m1 and m2 respectively with m1 greater than m2 are moving with same velocity v. The force required to stop the heavier ball A is more than that required to stop B. Thus, A has more momentum than B and the heavier ball has greater momentum. So here, elephant also greater momentum than ant. Thank you, students. I think so you have understood this slide properly, because you generally used to request me for these examples. That's why I am showing you this example in a different manner. Now in this slide, I am going to discuss the examples of Newton's third law. Newton's third law states that for every action or force in nature, there is an equal and opposite reaction. In other words, if object A exerts a force on object B, then object B also exerts an equal and opposite force on object B. Object A. Next, so that we can say here, so action and reaction forces are equal but opposite in direction. It should be noted that action and reaction forces act on differing bodies, that is, their points of application are different. Since two equal and opposite forces can balance each other only if they act at the same point, so action and reaction forces acting at different points cannot restore equilibrium. Now, you see the diagram. First diagram. A ball is throwing from this cannon, throwing out. But when this ball is going out, the cannon is moving back. This force is this direction. On the other hand, ball force is force on the ball in opposite direction. So this is action and this is reaction. One more time I am saying action and reaction. Okay. Now the second example. See this example. A man throwing his leg towards a building or towards a wall rather, you can say. Wall is not moving, but man is giving the action. This is action. He is giving the action. On the other hand, this wall is also giving a reaction. Actually, in real life, when you are throwing your legs towards a wall, obviously, slightly you are moving back because of the reaction of wall. But in this picture, it is not actually clearly visible, but actually it happens. So it is action and that moving back of that particular person is reaction. Now coming back to this slide. Here, when we sit on a chair, the downward gravitational force on us, that is our weight, act on the chair. This is action. The chair also applies an equal reaction force on us in the opposite, that is upward direction. Due to these two equal and opposite forces acting on us, we do not fall to the ground. It is to be noted that equilibrium is restored not between the action and reaction forces, but between our weight and the reaction of the chair, both acting on our bodies. Now see this diagram. If the chair would not have exerted a force, what will happen? We will be falling down. That is going to happen only. See, this is the actual reaction. If this will be not there, the chair would collapse and we will be falling down. Okay, now you can understand weight is action and this arrow, that means reaction by the chair, will be the reaction. That means action and reaction is maintaining Newton's third law. For subject-related doubts or queries, please email me at shudeshna1.sma@outlook.com. We also welcome your responses by way of your views and feedback on the PPTs or videos at feedback.stmichaelsacademy@gmail.com. Thank you students and have a nice day.